Okay, so our next question is permutations in which n people can occupy r seats in a classroom. Now, before going into the discussion part, I hope you must remember all the concepts that are related to permutations and combination, because this concept was the most important part of our maths. And when we talk about various exams, like various aptitude exams like GATE is actually conducted for higher studies and especially after engineering. So permutations and combinations is the main important factor there, and the problems are very complex and tricky, but the solutions are often one liner and two liner. Okay, here when we talk about this problem, permutations in which n people can occupy r seats in a classroom, we have formula for this, that is NPR. NPR is the formula, and this specifies that n factorial upon n minus r factorial. So let's say when we talk about n people, so let's say people are 5, so permutations in which 5 people can occupy r seats in a classroom, that is 3 seats in a classroom. Let's take an example. 5 people can occupy 3 seats in a classroom, so the n factorial will become 5 factorial upon n minus r, that is 5 minus 3 is 2 factorial. So 5 into 4 into 3, so that will be 5 4 is 20 and 23 is 60. So there are 60 ways in which 5 people can occupy 3 seats in a classroom. Let's see how we got into this solution, and let's discuss about logic first. Okay, now what I will do, I will delete all these things and let's get into the logic. Cool. Now I have 5 people in front of you and I have 3 chairs in front of you. So these ladies are identical, but let's assume with it. Okay. Now when you talk about finding the solution and how will you solve the problem. Okay. So let's discuss how will you solve the problem. Now the question was, in how many ways are there in which 5 people can occupy 3 seats in a classroom? Let's think about this lady. How many ways does she have to sit in these chairs? So there will be 3 ways. So she can either sit in this chair, she can either sit in this chair, or she can either sit in this chair, right? So there are 3 ways for the first person to sit in a chair. Okay, let's quickly write it down. So let's say she is the first person and she have 3 different ways. So there are 3 ways for the first person. Now she have occupied this seat. The first person have occupied this seat. Let me quickly mark it down. She has occupied this seat. Okay, let's go to the second person. So what will she do? How many ways does she have to how many ways does she have to sit in a chair? So there are only 2 options available, because this is occupied by first person, the first lady. Okay, so she will have 2 persons and she have chosen this seat. Okay, so she have chosen to sit here. Now let's get back to the third person, that is third lady. Okay, how many ways does she have? So she have only 1 way and she have chosen to sit in a third seat. Now let's go to the fourth lady and fifth lady. So there are no options left. Well, let's talk about this woman's perspective. So how many ways does she have? Let's identify this as 1. So how many does she have? She have 3 ways. So same goes. She have chosen this seat. So the first person that we have started with, she can either chose this seat, or this seat. Okay, she have chosen this seat, but she can also choose this seat. She can also choose this seat, and similarly the calculations are done likely. Okay, so there are multiple possibilities or multiple ways that are happening. See, we had n number of people, that is 5 number of people, and r number of chairs, that is 3 chairs. So the question was, how many ways are there in which 5 people can sit in 3 chairs? Okay, so let's quickly understand using and r. So for the first chair that we had, how many ways will be there for n number of person to sit in a chair? It will be n. Because n people can sit in first chair. Let's take an example of 5. If 5 people are there are 5 options to sit in either the first person can sit in first chair, or second person can sit, or third or fourth or fifth. So there are n ways in which the person can sit in first chair. What will be for second chair? So what will be the ways for second chair? So there will be n minus 1 ways, because the first seat has occupied. This first seat has occupied. Let's say the 5 person have chosen to sit on a first chair, but only 1 person will be able to sit. So let's take how many person will be left to be seated. So there are 4 number of people who are left to be seated. So that's what n minus 1 is. So for second chair, there will be n minus 1 person. What will be for third chair? What will be for third chair? It will be n minus 2. Similarly, we have chosen this 3 chair, that is primarily, but what about r chair? So there are r number of chair, let's say. For rth chair, how many ways will be there? So the ways will be, you can see the pattern here. You can see the pattern. For the first chair, there was no minus 1 here. So basically it was minus 0. It was minus 0, then it was minus 1, minus 2, and likewise. So basically you can write this minus 0 as n minus r minus 1. So r is basically the seat number, 1 minus 1 0. Okay, here you can also write n minus r minus 1. R is 1, so 1 minus 1, r is 2 here, so 2 minus 1 is 1. So the answer is n minus 1. There are n minus 1 ways. So when you conclude this, for r number of chairs, there are n, let me quickly remove this. So there are n minus r minus 1 ways. Okay, now when you think from a permutations perspective, so when we talk about permutations and combinations, the permutations are actually multiplied. Okay, the ways are actually multiplied, because for the first chair there are n ways, for the second chair there are n minus 1 ways. To together make this work, to together make this condition work, the answer will be, the number of ways will be, so the number of ways will be, and multiply all of them. So n into n minus 1 into n minus 2 into, because see, if n people have taken decision to sit in a first chair, then n minus 1 can sit in the second chair, then n minus 2 can sit in the third. So all of these conditions should go all along with each other. Okay, that's why we have multiplied it. And for last number, let's say it will go from here to here, and then we will have n minus r minus 1. Okay, so this is basically what we can do. We can group this n minus r. We can also simplify this formula. Okay, we will simplify this formula. So what will happen, it will, let's say, can you notice something? So n into n minus 1, n minus 2, it is actually n factorial. It is actually n factorial, and we can calculate this. So basically, let's say we have n into n minus 1 into n minus 2. See, the number is decreasing. The number is decreasing. So after some point of time, there will be 2 into 1, because give me a second. What will happen? Let's take an example of 5 factorial. I have told you multiple times the factorial, concept of factorial and how to calculate the factorial. So what is basically factorial? This is used in permutation. So it will be 5 into 4 into 3 into 2 into 1. Alright. Now let's quickly understand what is happening with n factorial. So n into n minus 1 into n minus 2. Are you getting it? So after some point of time, there will be 2 into 1. The number will start from always 1, because the number can't be negative, right? Factorial of negative is undefined. So the number can't be negative. So after some point of time, there will be 2 into 1 appearing in n minus 1, n factorial. Here what we are doing. Okay. So that's why what I have written this 2 into 1. Then what is this? What we can do? We can group this n minus r. We can group this n minus r, and we can do this minus 1, minus into minus will be plus here. So n minus r plus 1. Okay. N minus r plus 1. Now see, what is this? N into n minus 1 into n minus 2. What is this? This is n factorial. So this is n factorial into, we can simplify this. See, this is basically n minus r plus 1. What will be the previous value? What will the previous value? See, this is 1, this is 2, this is n minus 2, and this is n minus 1. So the numbers are increasing. So the value is basically n minus r. So this is n factorial, n minus r plus 1. Okay, so it will grow. This is n minus r plus 2. Are you getting it, guys? So after this, the number will be n minus r plus 2. After that, the number will be n minus r plus 3. Okay, I have written in reverse order. Because the order will be, see, this is plus 1. Previously it will become n minus r, then it will become n minus r minus 1. I have written in plus order. So what we can do, we can actually divide with n minus 1 factorial. So what we can do, we can actually divide by square of n minus r factorial basically. Let's divide it. So n minus r factorial into n minus r factorial. The reason why we are doing is, this is n minus 1 factorial. Are you getting it? So this is, let's say n minus r is r for the sake of exponential. This is p, let's say this is p. So what will happen? It is p plus 1 into p plus 2 into p plus 3. So this is basically a p factorial, right? This is p factorial, that is n minus r factorial. So we can directly write n minus r factorial. That's why we have multiplied it, we have divided it into n minus r square. So this n minus r factorial and this n minus r factorial will be cancelled out. So the final result, that the final formula that we have with us is n factorial upon n minus r factorial. Okay, so for n number of people to be seated in a 3, now let's talk about question. So the ways in which 5 people or n number of people can sit in r number of chairs is n factorial upon n minus r factorial. So for the, let's say this is the formula given to us, and let's take an example. If we talk about 5 people can sit in 3 chairs, so 5 factorial upon 5 n minus r factorial, that is 2 factorial. 5 minus 3 is 2. So 5 factorial is basically 5 into 4 into 3. So 5 into 4 into 3 into 2 into 1, and 2 factorial is 2 into 1. So this 2 into 1 and this 2 into 1 will be cancelled out. So 5 4 is 20 and 23 is 60. So there are 60 ways. So this is the logic. Okay. Now let's quickly see the pseudocode. We have 2 numbers given with us, that is the n number of people. Let's say n equal to 5 when we have taken example, and r equal to 3. Okay, so I have defined it personally, but it can be a user input as well. Let's write a function, factorial function first, because ultimately we will need to calculate the factorial, right? So let's take an example of factorial. And in factorial, what was happening basically, we will write a recursion function. Let's say example of n equal to 5. So 5 factorial was basically 5 into 4 into 3 into, so the numbers were decreasing, So a number will come, fact of n, and basically a parameter will be there. Now what we can do, a base condition will appear here, a base condition, and after the base condition we will return a value, and the value will be n into fact of n minus 1. So number is basically decreasing, and we will check if my number is 0 or my number is 1. If my number is 0 or number is 1, we can return 1, because factorial of 0 and factorial of 1 is 1. Okay, so this is my factorial function. I hope you remember this. If you can't understand this concept, I have talked about factorial number in the factorial function. I will mention it in the comment section or the description. Okay, so you can watch it from there. Cool. Now when we talk about calling the function or using it, the formula was basically n factorial upon n minus r factorial, and factorial divided by n minus r factorial. So we can directly take the result which is factorial of n. So we will pass this n, and we will divide this number using factorial of n minus r. We can directly do this. Okay, so this is how we can simply print the result. Okay, now let's try to incorporate this into actual code. Thanks for watching. Okay, now let's code this permutations in which n people can occupy r seats in a classroom problem. Okay, now I have explained you everything about it. Now let's just into the code. So here I have declared a fact function which is actually going to calculate the factorial of a number, and it's a recursive function we have seen in multiple videos. So if n is equal to 0 or n equal to 1, so this is the base condition, we're going to return 1, and we will have written n into factorial of n minus 1. It's very simple. Here I have declared 2 variables, that is n and r, n for number of people and r for number of seats. So here I am taking the input from the user, and here in number of permutations I am calculating, that is we have formula n factorial upon n minus r factorial. Okay, then this is what we have calculated. So factorial of n, we can call this function here, and we can divide the number by factorial of n minus r. Okay, so after that I'm just going to print out the number of permutations. So if you try to run this problem, so here let's see the same problem, same question that we had, that is permutations in which 5 people can occupy 3 seats in a classroom. So what should be the expected output? So expected output should be what? Number of factorial of n, that is 5 factorial upon 5 minus 3, that is 2 factorial. So 5 4s are 20, 23s are 60. So output should be 60. If you try to run it, you will get 60. Okay. Now if you try to make it a more larger seats, so more seats, you have 120 possible ways. Okay. Now thanks for watching the video.